So I'm going to talk about the Heathkit Capacitor Decade Boxes, and they basically had one design, and I'll go through Chuck Penson's excellent book on Heathkit test equipment products. So Heathkit's first capacitance decade box was the DC-1, which appeared in 1952, and this basic form in a nice birch cabinet with silver mica 1% capacitors was made until 1962. However, in 1954, under the same model number, DC-1, they came out with a restyled front panel where they just changed it from a beige paint scheme with black trim to the dark gray paint scheme with white trim. Everything else being the same. So again, that was still called the DC-1. That was replaced in 1962 with the IN-21 right here. So this was made from 1962 until 1967. Same exact circuit, although they did change from the silver mica capacitors to more modern types that had similar characteristics. In 1967, the restyled IN-27 came out. Same exact thing, just a case change. They went to the classic beige design that some other test equipment I've highlighted in my videos is in that same paint scheme. So it was going into the later 70s, which is in line with the other ones I have. For some reason, Heathkit stopped having a capacitance decade box after 1977. For a couple of years, their catalogs did not have one. And suddenly, that same design, the DC-1, IN-21, IN-27, reappeared in the 1979 catalog as the IN-3127, and this time it was in the sort of eggshell and Heathkit blue paint scheme. I have had one of these for a long time. I'm sure I built it in the late 70s. It was probably one of the things I built shortly after I built my small Heathkit power supply that I've had a video on. And again, it's the same design as that classic DC-1. All they've done is restyled the case and modernized the types of capacitors are used internally. Now, Heathkit did have other capacitance boxes, but they weren't decade boxes. So for example, let's see. Yeah, they had the IN-22, for example, which was a restyled CS1. So that started out with this one, the CS1, and then that went to the IN-22, and then that was replaced by the IN-47, and then replaced by the 41 or 3147 right here, which was the last one they made. So they had 4 versions of that, but that wasn't a decade box. It was just a few capacitor values in a box that you could select from, but it was not a decade box. Now, along with the DC-1, Heathkit also had a comparable line of resistor decade boxes that they went through numerous variations, but I'm not going to go there in this video. Alright, this shows some of the appalling solder jobs that were on the common bus bars. This bus bar goes right through the hole and isn't even soldered. This one wraps around and has a solder glob on it, but it's not soldered to the terminal. And similar things here with the other bus bar, just barely making contact, if at all. Here are the solder tabs for the two terminal posts, and once again big blobs of solder, but they're not actually, the solder hasn't actually wetted the actual lead or wire. So here I've desoldered everything, the capacitors, the bus wires, everything came off, and all excess solder was removed, and then I scraped the oxidation off of all switch terminals, and I'm going to provide new bus wiring. And I've also straightened and scraped the leads of the capacitors. Here are all the silver mica capacitors with their wax coatings after the leads have been straightened and cleaned up. I wanted to make sure all of the capacitors were still at that correct value and functioning as capacitors, so I'm using my handheld capacitor checker. And here's the first capacitor. It's a 10,000 picofarad, which is 10 nanofarads as the meter reads it. Seems like the accuracy is quite good. It's supposed to be 1%, so it's in the ballpark. And here's checking all the others. The 20,000 picofarad, or 20 nanofarad. 30,000 picofarad, or 30 nanofarads. 40,000 picofarads, the O is missing, or 40 nanofarads. And the next range, 1,000 picofarads, or, well, it's actually showing it in picofarads there. 2,000 picofarads, or 2 nanofarads. 3,000 picofarads, 3 nanofarads. 4,000 picofarads, 4 nanofarads. And then the final range, this is 100 picofarads, and it shows it as such there. 200 picofarads, shows as 204 picofarads. 300 picofarads, it's about 305. And finally 400 picofarads, reading at about 404. It's a little hard to see in this photo, but I've put in new bus wiring along the tops of the switches and along the lower wafers as well to the two terminal posts. You may wonder why there's strips of blue post-it notes surrounding the screw terminal solder tabs, and that's because instead of being on something like black bakelite plastic that they're mounted to, it's actually a clear piece of acrylic, and I didn't want to have the splashing from the solder flux all over it, so I was protecting the clear plastic using those strips of paper. The other thing to mention here is that when I had the switches all desoldered like this, I used some deoxit on the contacts and worked them back and forth until I was sure that they were making good contact. And here's where I'm soldering the capacitors back onto the switches, one switch at a time, trying to keep them neatly arranged. And all the leads are wrapped once around the terminals instead of a big knot of them like it was before. Here are some views of the much neater solder joints that I was getting. Here's a view of the birch cabinet. The corners are stapled and reinforced with those wedge-shaped pieces. The back is masonite, so it's really only the sides that are birch. Here I have my capacitance checker hooked up, and I'm just doing some tests of various combinations of the switches to make sure that the proper capacitance is read. I'm going to show a video of doing some of that. Alright, I'm reading about 8 picofarads with everything turned off on here. Now I'm going to go up to 100, and it reads about 110, so it's reading roughly 10 high, and that's 213, should be 200, 313, 414, 517, that should be 600, 700, 800, 900, and 1,000 picofarads, reading approximately 19 picofarads high. So now I'm down to the 0.001 microfarad range, which is about 1,000 picofarads, and that's what it's showing. I'm going to go to 2 nanofarads, same thing as 0.002 microfarads. 3, 4, 5, 6, 7, 8, 9, and 10 nanofarads, or 0.01 microfarads. I'll take that back down to 0. Now I'm going to go for 0.01 microfarads, which is 10 nanofarads. 20, 30, 40, about 50, 60, 70, 80, 90, ooh, right on the money, and 100 nanofarads, or 0.1 microfarads. And of course I can use them in combinations. I can have 0.15, or let's see, 0.1005, or 0.105, that's what I meant to say, which is what it's doing here. .106, .107, and so on. So now I'm going to call up a 2 down there. A 3, and that's going for the 2 orders of magnitude lower, so we're getting into the weeds on that. Don't expect it to be glorious. When I'm calling for a much higher value, I expect the lowest number to be well into the error of the meter. Okay. So now it should read close to 300 picofarads, which it does. So I know the caps are correct, it's just the meter can't read it accurately when it's way down in the lower numbers of a lower fractions of a larger number. Chuck Penson's book does mention, just as I found empirically, that the parasitic capacitance is somewhere in the 10 to 15 picofarad range, even with all switches set to 0. So that was not a defect due to age, it was consistent with the design. So there it is, all restored. Case is in good shape. I think those are the original felt pads on the bottom. Somebody wrote their initials and presumably the date they finished it, 1969. Perfectly usable capacitor decade box. I don't know what the voltage ratings are for sure, and the values are good, but they may have aged in other ways. I don't actually plan to use this. It's awfully big compared to the other ones I have, but still a pretty cool piece of vintage kit. So while the DC-1 was Heathkit's first capacitance decade box, this model IN3127 that I've owned for many years is the last model that Heathkit came out with in a capacitance decade box. So these two that I own are really spanning the entire breadth of Heathkit's offering in this type of device. So this is basically the same product, functionally anyway. The Heathkit was really making the same basic design over and over, changing the housings and so on, but the circuit was exactly the same. This is my capacitance checker that I've had and used for a long time, although I haven't used it recently. And it has the same selectors. It has 0 or off to 10 on 3 ranges, 0.01 microfarads, 0.001 microfarads, and 100 picofarads. It's just the same as the other one. And if we open it up, we even find the inside is basically the same. The difference is that the types of capacitors are not the same. They're not using the old silver mica. They're using some mylar caps and so on in here. Different types for the different ranges, but basically the same deal. Same exact circuit. The switches do the same thing. There's 4 capacitors per range that are just used in different combinations to get all the possible values. Just as with the older one, there is some residual capacitance when everything is turned to 0. In this case, it's roughly 10 picofarads. So I'm going to go up through the smaller range here. It'll be 1, which is 100 picofarads. Everything's times 100. So 100 picofarads plus the roughly 10 picofarad parasitic value there. 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are all pretty good. They're reading really close to their specified value plus the parasitic value. Now I'm going to go to the 0.001 microfarad. There should be that, so 1013 picofarads. 2 nanofarads. 3, 4, 5, 6, 7, 8, 9, and 10, or 0.01 microfarads. Same thing as 10 nanofarads. And finally the 0.01 range, so that should be 0.01 or 10 nanofarads. 20, 30, 40, 50, 60, 70, 80, 90, and 0.1 microfarads, or 100 nanofarads. So it's performing very similarly to the old one. While I don't own a manual for the DC-1, I've been trying to find one for quite some time, and finally, just before I started making this video, somebody had a copy listed on eBay, which I've purchased, but it's going to take a while to get it. They promised to send it media mail I don't know why anybody actually does that. It just irritates customers, but anyway, I do have the manual for the IN3127, and I expect they're going to be virtually identical in what they cover. So something this simple doesn't really require much of a manual overview anyway, but I'm still going to do it. This one's going to stand in for both the IN3127 and the DC-1. So small manual, small product. Copyright 1978 on this particular manual. Got a nice overview page, table of contents. There aren't a lot of parts, so the inventory of parts is pretty simple. Hardware miscellaneous, different parts of the manual, inserts, and they get straight down to assembly, putting in the binding posts, mounting the switches, pushing the inserts into the knobs and pushing the knobs onto the shafts of the switches. And then the actual electronic assembly starts here with cutting the bus wires and soldering them up. And then it refers to the illustration book for all the other diagrams for mounting the capacitors. It just sort of says, well, go down this list of capacitors and install them. And there's only 12 capacitors, so it's one whole page of instructions. And the actual pictorial is in the illustration book, not in the manual proper. And then we put the feet on. Finish assembling the case with 6 screws. Basic operation, as it says, the Decade Capacitance Kit, and for some reason they call it a kit here instead of a capacitance box, which is what it's called elsewhere, is very easy to operate. Simply connect it to the circuit under test and adjust the range switches for the particular capacitance needed. The total value of capacitance is found by adding the settings of the 3 range switches. For example, if the times 0.01 microfarad range is set at 8 and the times 0.001 microfarad range is at 2, with the 100 picofarad range switch at 0, the total capacitance presented at the binding posts will be 0.082 microfarads. You should keep in mind that approximately 13 picofarads is always present at the binding posts and must be added whenever it presents a significant portion of the total capacitance involved. In applications where this might be important, make sure that the black binding post is connected to the lower impedance point of the circuit under test. It is not advisable to connect the red binding post to the lower impedance point because of the variation of stray capacitance that can exist at the binding posts. Regardless of the application, make sure you observe the voltage limitations listed in specifications. And then there's a brief, in case of difficulty, section. Specifications, already covered it. The ranges, the voltage, the different types of dielectric, mica, polystyrene, and mylar, accuracy in the different ranges, stray capacitance 10 to 15 picofarads at terminals, dimensions, weight, circuit description. Circuit incorporates 3 convenient range switches to select any capacitance from 100 picofarads to 0.111 microfarads in 100 picofarad increments. The capacitors that are used have a very low dissipation factor and internal resistance. As you rotate the range switch, it automatically selects one of, or a combination of 4 capacitors. This capacity is then presented to the binding posts. The 4 capacitors of each switch are appropriately paralleled to complete the upper range of the switch. Blank page, customer service. Now the illustration book. This is the one that shows pictures of all the components in the kit. Not a lot of them. And here's where it describes how to bend the 2 bus wires into shape with their critical measurements, and they include a handy scale right on the page so you can use it to bend the wires against that. And it says to make sure to bend the bus wires down at an angle, and then the other bus wire goes up higher, and it shows a very clear illustration of those two bus wires and their connections to the binding posts. Then one other illustration showing how to connect up the 4 capacitors per bank from the switch terminals to the bus bar. Once you've figured out how to do one, you can do them all. And finally, the other insert of the manual, which is the electrical schematic. Now this is a case where I always thought Heathkit screwed up. They usually had pretty nice schematics, but their tendency to show rotary switches in this format, which are not very easy to figure out how the switches work. If it only has 2 positions, you can figure it out easily enough, but I was puzzling over these, trying to understand. You have to keep in mind there's a lot of positions. There's 11 positions per switch, and trying to figure out where each tab and part is going to be in all those degree increments. I challenge anybody to keep that in their head, trying to figure out what's connected to what. Of course, you can figure it out by knowing what must be connected, but to actually tell it from here, good luck with that. I always thought they should have just shown a proper electrical schematic for these switches, but they didn't. This was Heathkit style. Anyway, so you can see the 4 capacitors per bank. The schematic is exactly the same for each bank. The only difference is the capacitor values. And then, of course, each bank is wired in parallel with the other 2 banks. It couldn't be much simpler than that.